We have another topic, like one connector, many Savarians. Thank you, Sava, for coming on stage and presenting another way how to rein them in. And actually, sovereignty, honestly, does not mean that you have to do everything yourself. It means that you have strategic options available. And the connector software, of course, is one of those strategic options where you want to have more than one to choose from. The floor is yours, Sava. Thanks. If you introduce yourself, of course, yeah.
So, good morning, everyone. Just a brief introduction. My name is Sava. I'm one of the representatives of MicelioData. And to give you an idea, we're building the textile data space. So in a nutshell, our goal is to connect the Asian supply chain with the European market. And this is largely driven by the regulation that's coming up now. So during our work trips in Bangladesh, where we tried to present this concept, we encountered a fundamental problem, and is that most of the supply chains, specifically tier 3s and 4, don't have the digital maturity to implement this concept of data spaces. So what I'm presenting today is not a finished product, is the technical direction we're currently developing through collaborative research and real supply chain deployments. Let me see. So I wanted to show these three numbers on the screen just to give you an idea. And our data space is built on EDCV, DSP, and Gaia-X infrastructure. As I mentioned, we're still in deployment and not production, and this is architectural work. So the three numbers, as you can see, 95% is a number that I didn't make up. It was mentioned in the Data Space Adoption Forum, and it states that most of the SMEs nowadays cannot still access the data space itself. Roughly 70% of textiles are coming from Asian countries, some that we're working already with, so Bangladesh, Turkey, India, and Vietnam. And thirdly, 2028 is when it will be mandatory for European brands to comply with these regulations. So they need to provide and have the data in digital format. So just to be a little bit more concrete, I just wanted to show briefly how the supply chains actually operate in Bangladesh. This is something we validated when we went there. So they use mobile phones. Their ERP systems are WhatsApp messages. So they do quality checks on photos. Their production records are kept on handwritten notes. They sign contracts by handshakes and by no digital signatures. And lastly, they have no ERP system, no server, no IT department whatsoever. So this is something that this is not an edge case. In our case, it's the model case of the manufacturing, and this industry is what produces the majority of the textiles coming to Europe. So let me talk a little bit about technology, because that's why we're here. So the good news is community has done quite some work on the infrastructure for multi-tenancy. Our stack is built on open source multi-tenant onboarding toolbox, and it's operated by the EDCV, the contract fabric manager, and the JET demonstrator. So this infrastructure is what will allow for us to reduce cost and onboard multiple participants at once. As you can see briefly, the layer 1 is the connector fabric manager, and this handles multi-tenant provisioning, lifecycle management, and certificate rotation, and exposes the management API. The JAT is what assembles all this in a user interface and allows it to be operable. The layer 2 is the EDCV, so this is a cloud-native optimized version of the Eclipse data space component. And it's designed for cloud scale and virtualization. So instead of running heavy resource containers for every single supplier, the EDCV runs multiple participant contexts inside a single GVM runtime. And layer 3 finally is the data space itself. So this is where the DSP, the negotiation, and the brands actually operate. So our protocol stack is DSP over HTTPS, the DCP for identity, and the management API for the communication between the CFM and the EDCV. So the architecture is brilliant. I mean, it looks, it solves the problem of multi-tenancy and onboarding at scales, but even though with this toolbox, there's still some unspoken assumptions regarding the real situation in the world. So in summary, the supplier must have some technical digital maturity, They must be able to manage or host their credentials. There must be some person or IT department that can actually interact with the data space itself. And their data must already exist in a digital format or a standardized format compliant with the data space. So this is what we're solving apart from the data space build out itself, is the last step we're building. So like I mentioned, those are some assumptions that a service provider or an MSP would need to host in order to allow these low-tech participants to interact with the data space. So firstly is the sovereignty. The participant needs a DID, as we know, a VPN, a verifiable credential. So this has to be provisioned, hosted, rotated, and maintained transparently. This is something we cover with the EDCV, and this is tailored to our solution thanks to the community work. The second one is the standardization and the interoperability. So the information, like I mentioned, that suppliers provide is normally unstructured and unverified. They use voice messages, photos, handwritten documents. So this will need to be extracted, structured, mapped to the requirements, and transformed into machine-readable formats. Third is the sovereignty and storage. So even if the intermediary operates the infrastructure, the supplier still needs to be encrypted and isolated. And fourth is the policy generation itself. So suppliers cannot read or write ODRL policies, so we need to develop models that allow, was mentioned previously in previous presentations as well, but we need to translate those plain languages governance to ODRL policies. So, and finally, lastly, I forgot, is the contract negotiation as well. So even when a participant, an intermediary, or us in this case, operates both sides of the exchange, the supplier-facing EDC in the instance of the brand request, we still need to keep the EDC contract negotiation live. And this is not optional. This is because the contract negotiation law creates a traceable, timestamp, policy-bound evidence that allows this data sharing and keeps it in record. So this is the architecture on the right-hand side, what we're proposing. So like I mentioned, the interface as well, this is what I'm presenting now. So this is what we're building that's going to sit on top of the multi-tenant EDC infrastructure. And that's our semantic, well, that's our called MIA, it's our system. It's an MSP, but it also acts as an intermediary between the supplier and the data space itself. So to dive a little bit deeper, MIA has 4 components, and the first one is the UI interface. So this is a multilingual WhatsApp-based and interface designed for zero login complexity, so it allows participants to participate with the space accurately and really easily. The second is the semantic engine. So this is an extraction engine that takes unstructured inputs and maps it to the vocabulary automatically. This is a MIA AI native mapping policy to execute OCR parsed inputs. So it takes images and it converts them into structured data. We map this to a UTO that we're developing ourselves. So this is a textile ontology we're defining for the data space. And this is synthesized into a single OWO RDF semantic graph. So semantic graph, yeah. So it's built on 3 international standards to guarantee cross-border interoperability, and is the EBS TCF for textile-specific vocabulary, the GS1 EPIX for traceability, and the UN SECAT for international trade documentation. This also, currently we're mapping 72% of the requirements for the digital product passports in this case, and we're still waiting for the delegated act to come through. The third is the policy translator. So this is the engine we're developing to translate the ODRL policies in plain language to machine-readable formats, and reflect them actively in the EDCV. And lastly is the identity broker. So this is a managed wallet. So to prevent building a centralized system inside MIA, the platform does not store or execute the supplier's private keys within its own database. Instead, what MIA does is it acts as a secure neutral signaling agent implementing standardized managed identity wallets. So when a factory is onboarded, MIA triggers a CFM triggers the connector fabric manager, to programmatically provision a logically isolated and context-bound directory in the HashiCorp Vault and the EDCV multi-tenant identity hub. And this dynamic configuration ensures that even if multiple factories at the same time share physical Vault instances, their private keys are isolated at rest. And this also I wanted to emphasize, because one of the questions I was having is, are we not locking in the vendors? And this is not the case, because if the factory grows in digital literature and establishes its own IT department, as the software is developed on virtualized components, the trust context can be migrated directly into self-hosted single tenant connector with zero vendor lock-in. So this allows other participants, if they want to, get away from our solution. And this is a technical hypothesis we're currently validating in Bangladesh through multiple participants, universities, as well as 6 manufacturers that export already about 3% of the total exports to the European Union. And I wanted to mention that this is not a graphically isolated problem. This is a still global gap and still needs to be addressed in Europe and in Asia in general. And I think with the adoption and the help of the community in general, we can make this problem and solve it to onboard the data spaces at scale. So thank you very much. I kept it brief, and hope you understand it. If there's any questions, please let me know, answer, and I'll help you. Thank you very much.
Very nice. I think